Check. All right. I think we have volume. Let me check my sound real quick. Ah, cool. I think that should make it a little bit louder. So I think we're good. Cool. So today I just wanted to kind of just run through building a agent. But let's just talk about like why you'd want to use a state machine. At the end of the day, making agents is hard, and particularly to make them reliable. And if you want to make them reliable, the key is to make the state action space smaller. The more actions an agent can take, the more likely it'll take the wrong action. The more states the agent can possibly be in, the uh, or the larger that the information is of the state, the more likely it is that the agent's going to get confused. And so, both how many actions you can take and how many states you can be in kind of contribute to the reliability of the agent. And so, one helpful trick is to kind of structure your states and actions into a state machine so that you have more controlled transitions between states and available actions. And what that does is it kind of reduces the effective size of your state action space and makes it easier to make things reliable. So, all that being said, maybe I'll just show a quick example of um, a graph with Pydantic AI. So, when we the Pydantic AI graph functionality, that's kind of like how you build a state machine for Pydantic AI. So let's look at this generative AI example they have. So they have this sort of feedback graph with write email and feedback. And there's this dot here, which is really your start state, and then this sort of end state over here. So if we go through and look through the code, they have defined a user class. That's just a simple data class. They defined an email, and they defined a state. And the state takes two things. It takes a user, and then it takes the messages that the write agent should use. And the state is something that's common amongst all nodes in the graph. And something that might be confusing thinking about this like a state machine. The uh, if you look at the literature of state machines, a node in Pydantic AI is what would correspond to a state in the literature of state machines. And so, easy to get confused here because here each node has a concept of state that's shared. And so this is where we can kind of like put any data that we're going to need to retain as our program runs. And so they create an agent to write an email, and then they create a node that uses that agent. And so every node can have essentially some input that's just defined uh, as a attribute, and then it defines a run function. And the run function basically can return whatever it needs to return. And so this write email, since it specifies state, this means this cannot return the end node. So there's a concept of an end node that's baked into Pydantic AI. And so we can see on this feedback node, we kind of have like this email type at the end. And so like this is what like specifies that like this can return an end. And so really what we can see is, this write email is basically going to check to see if there is email feedback. So the first time you try to write the email, there's not going to be any feedback. And so for the first time, this would go to the else statement and then, give this prompt, blah, blah, blah. But if there is feedback, then, you rewrite the email for the user, blah, blah, blah. And so then we define two classes, email requires write or email okay. And so notice we create a feedback agent which can either return that email requires write or the email okay. And so the model can decide, do we need feedback or not? And if we need feedback, what is that feedback? And then you give it the system prompt there. And then we create another feedback node. And so you'll notice that there's kind of like some layers to this. There's essentially the agent, the structured outputs that it returns. There's the state, the node to run it, and then we're going to put all that together into a graph. But if we look at the feedback takes an email, and again, this email writer agent outputs an email, and then taking that email, we create a prompt, and then we run it with our feedback agent, and then we check to see, does it require does it have feedback? And if it does, we're going to return write email and then pass in the email feedback that we had. So we're basically inside each node, you're returning the next node basically. And so this is kind of awesome because it allows you to intermix sort of the LLM parts of logic and then also mix in deterministic code. So definitely like a cool like model on a programming model of how to do it. But yeah, so this is the basic thing. So now that I've kind of like shown you through like what this looks like, let's talk about sort of the problem that I want to solve. So this is just something that's kind of dumb, but I like to look at my social metrics and just kind of like track to see what content's doing well. That way I understand like what is the type of stuff people like to see. So I can do more of that. And so if I go and like look at my analytics, there is this handy dandy page where you can see basically, for instance, if I want to look over the past 90 days, I can see every post I've made with the number of impressions I've made. And then I can also switch this to show the engagements. I would love to get this in a table so then I can kind of like do some other analysis on it, but extracting it might be difficult. So again, I don't know if this is going to work out, but we're just going to see if this goes. So, where to begin? Well, I already installed the libraries, and I think I created a main file. Cool. So, what we first need to do is just import the stuff that we need. Um, and so, we're going to kind of build this up slowly. So, the first thing I want to do is set things up so an agent can do browser use. So, I'm going to say async def main, and we'll do pass, and then if. Cool. And so now we're going to set up an MCP server for a browser use. So we'll go ahead and just kind of like copy a lot of this stuff in, just because it's not going to be very different. And so I'll just say browser use, and then we can go into the browser MCP, and so we can figure out how to basically run this on stdio. And so this is the stuff that we need. So command is npx, and then this is the args. So wait, let me see. Oh, the command is the first argument. So I thought it was a name. My bad. Cool. And so now we have like our little browser use thing set up. Cool. And so now we can create a little agent. And there's lots of things you can provide for the agent here. So you can give it like instructions or system prompt. So I might say something like, just so we see that it works, we'll say system prompt equals navigate to google.com. and search for Python. And now we can basically await agent.run. So we've given it access to the browser use through this. The way that browser use actually works is I basically have to connect it here. So now this tab will be what it uses. And so we'll go ahead and uv run main.py. And so we see MCP server is not running. Let me okay. Async with agent.run MCP servers. So that's why. So we need to do async with agent.run MCP servers. Okay, cool. So this way, so this is the thing that kicks off the running of the MCP servers. So that's what I missed. Okay, connection closed. This is still connected. So let's see. Asynchronous generator is already running. Here we go. Oh, I think because this has double quote, this is like double quoted. I think that might be a problem because it looks like it wasn't able to run it. We'll see if that fixed it. I don't think this did anything. So maybe I'll change the system prompt to say use browser tools to satisfy the user's request. And then agent.run, I can do that. Okay, this wasn't connected. Let's try that again. And then if this still doesn't work, so this doesn't seem to be doing anything. So I'm not sure. I haven't used MCP with Pydantic AI, so I wonder if there's like logging I can enable. Like, what if I run this and I don't know if let's see if there's like something about logging in here. Messages, chat history, output, debugging, monitoring. I don't want to use Logfire right now. Honestly just want to like output logs to the terminal. So I wonder if I look up log. Yeah, it's pretty annoying. It's pretty annoying that they don't have any way to like show what's happening underneath the hood. This is one of the reasons, by the way, people give the advice of don't use libraries that take away the control flow. There's a lot happening under this run function. And if it works, awesome. But as we can see, it does not work in the way that I expect it to. And it's quite difficult to understand why. Um, So maybe one thing I'll do is like say output the title of the first result, and then we'll like print that out. That way, like something needs to happen, needs to output something. It could just hallucinate something, but maybe the output will give us a little bit more insight into what's happening. Okay, so now we see it works. We can see that, this navigated to Google and then searched for Python. And so we see that it pulled out the title of the first page. So cool. So we got the MCP working. Now, kind of like going back to the original sort of thing that I had, the task. So we know that we have a URL. So like we can say like LinkedIn Analytics URL. We can go grab that. And notice that there's this metric type equals impressions. And so it seems like a lot of what's in, so we can also just like modify this to get the whichever metric we want. And so we might do something like this. So now we have two URLs to keep in mind. They both kind of like are the same thing. And so now we can kind of like start going through and building up our agent using a graph. My advice always is to build incrementally. Don't try to jump straight to the end game. So I already know I'm going to need to navigate to one of these pages. So the first thing I'm going to do is just see, can we navigate to the page? And so, I might want to make a node. So first of all, we're probably going to want to make a state. I'm just going to leave it empty for now because I don't know what we need to put in there. And I don't want to think about it quite yet. Um, but what we can do now is define our nodes. And so one of our nodes is obviously going to be like, navigate to page. And probably we're going to want it to take a URL. And then, and actually this needs to be base node state. Let me just make sure this is like the right thing to import. So from Pydantic graph, import base node. Let me go back to this Gen AI example because I think this was the cool. So cool. So now we got the things that we need to import. I got a base node. And so we can see that the base node, or anything that inherits from the base node, the run basically, the run method returns whatever nodes that it can transition to. So this doesn't need to do this. Um, mm, mm, mm. So we can basically have it navigate to a page, and we're just going to have it pull out the number of impressions of the first post. Man, cursor tab autocomplete is actually getting quite annoying for me because it's like very rarely I actually want to use it now. Um, So anyway, we're going to now return an end note from this. So what we're going to do is just set up an agent, and all it's going to do is navigate to a page. And then we're going to basically run the agent with that URL, and then have it extract out the final result. And so the way we do that, we should probably move this agent stuff up a little bit. And so here, we're going to want this agent to just be able to navigate. And so this is fine how it is. But what we're probably going to want to do now is on this navigate to page, we want to use this agent. And so we can say result equals await agent dot run. And the other thing we're going to want is to basically provide the output structure that we want to use. I forget what the argument's called. I think it's output type. So output type equals final result. And so we're basically now saying like, hey, this agent is going to use those browser tools to satisfy the user's request, and it's going to return this final result. And then we're going to get the result from the agent. Let me look at the definition of run again. Okay, yeah. So this is missing a self. And then we want to return end with the result. So basically what we're doing here now is we're kind of forcing the AI to stop once it gets to like this final result. And this might not be the actual final result, but helpful to kind of like structure it in this way. But basically, we can now, instead of having one really long running agent, we can chain them together with these state machines and have smaller focused specialized agents. But still kind of have the experience of it's just kind of like one agent running. So we got all this in here. We don't need anything in the state yet. So I think this should be good. The only thing we need to do is look at how you actually run the graph. And so basically, this is how you do it. Um, you create state, and we don't need to pass anything into it because our state's empty. We need to create the graph. And the only node we have is navigate to page. And then you can run the graph and you tell it which node to start on and give it the state. And then you can print the final result. So now let's go ahead and see if that works. So I'm going to kind of close some of these things that I'm not using anymore. And then we'll reconnect this so we know it's like fresh. And so let's see what happens now. Navigate to page takes no arguments. So I'm wondering right now, So again, I haven't used this functionality yet. Um, I just assumed this would work similar to a base model, um, where I could just pass in the stuff without having to write my own in it. Takes no arguments. Um, so I wonder, I might need to like separately also inherit from base model. Okay. Okay. So I got a warning first of all, where said, "Hey, inherit from base model first." It's cool. But one thing I saw is that, nothing happened here. I'm surprised we didn't get an error for not having. Okay, I guess we have our run with MCP servers. And so one thing we can do in here is basically print navigating to URL, and then we can also print the result. And that way we're getting some semblance of what's going on. So we can see we're navigating to the right page. So it navigated there. And then first entry 5601, and we see that's how many impressions. So cool. We're like making some progress here. So let's continue on. So next thing we want to do is after you navigate to a page, we're going to want to scroll down to the end of the page because this doesn't load everything at once. And so basically, once we're on a page, the next action that we're going to want to take is to scroll the page. So we'll say class scroll to bottom. Um, and so this actually doesn't need this final result anymore because we're not going to let it end from here. And so instead of returning this, we're literally just going to return um, uh, scroll to bottom. And so this isn't going to need any sort of state. So we can literally just define the run. And for now, we'll say that this, you know, gives us an end. So we can basically now start to customize our agents. And so we'll call this a navigation agent. And so use browser tools to navigate to the URL specified by the user. And we now don't need this final result type. We could extract out something, but there's not really much to extract. As long as it satisfies the request, we're okay with it. And we can kind of just like drop whatever it is. Um, so now we can basically navigate. One thing we might want to do here, and I'll just like leave this as a note that I don't want to do right now. You could validate that the current state is correct. So it is totally possible the navigation agent messes up and doesn't actually navigate to the page that we think it should. And so you might want to check that. And so there are things you could do to validate that. Just because this is just for the sake of just exploration and learning and teaching, I don't think that that's necessary. But we'll still keep printing out the results here just so we kind of know what's going on. Um, and like one cute trick we can do here in the logs is just say like navigate to page. So we get like the name of the step or the node, and then we can like tab in the other things. That'll make it look a little bit nicer once we start to have more of these. And so now we can make just a simple scrolling agent. Or, oops, this is not a class. Scrolling agent. Scroll to the bottom of the page and return the content of the last entry. Um, and so actually, this might even be a thing where we don't need a system prompt. Or, you know, we might just be making it the same. So do something like this. Scroll to the bottom. Cool. So now we got what's here. Um, and so I'm also going to get rid of this final result type for now, just because we kind of have something that is like working for the moment. Um, and instead, we can just return end. And then this complaining to that. Cool. And so this is an interesting thing because we have multiple agents with MCP servers now. And I believe they all can use the same one. So I think we should only have to run this on one, but we'll totally see. So again, just like to start things fresh, just so we don't have old state potentially messing us up. And so now we'll start at navigate, and then navigate, we'll have it scroll to the bottom. And so we should basically see it navigate and scroll to the bottom. Oops, I still have a reference to final result. Ah. Hmm. Yeah, there we go. So this is because this wasn't defined yet. It's defined later. Ah. So the other thing I need to do is include it in this graph. Cool. So we can see it's navigating to the page. It's telling us that. So yep, it's navigating to the page. And now it's scrolling to the bottom. Ah, so end is missing. So we see here it didn't actually scroll. And so that's problematic. And so maybe one thing, I wonder if we can just like return end without having to specify something. So let's just like look at like simple examples. And so we can probably just pass none into the end state. And I think this is technically, actually, I don't think we need to specify that. So one thing I want to look at is we had that print statement to print kind of like the thing. So this says, please provide a URL or website that you'd like me to interact with, and let me know what specific information you're looking for from the last entry on the page. Cool. So this tells me that it just doesn't understand that it's on the correct page already. And that might mean that maybe it makes sense to put these into the same thing. But suffice to say, let's just try to make it work just by letting it know it's already on the right page. You are already on the correct page. And then let's just like look at what's on this page. So we will always have like a number of comments, and so that might be just a good thing just to have it verify itself. Use browser tools to scroll to the bottom of the page and return the number of comments for the last post. And I think part of it is because of this. Let's like simplify this a little bit. Cool. So we've just basically updated the system prompt a little bit and then made it actually just a user prompt rather than having a separate system prompt. Okay, so I think it hallucinated something. Let's try to do this again. Another thing I'm noticing is that this is not really waiting for it to load. And so this is not actually like scroll all the way down. And so maybe I'll say like always wait for load for page load. And then, you know, I'm always a fan of like dumb hacks. And so maybe before we can basically just await sleep and we'll just like sleep for like 3 seconds. It's interesting to me that it is pulling 4 comments out. And I wonder if that's like just like the kind of end of the like first chunk. So I think getting it to scroll to the bottom seems tricky. It doesn't want to scroll. And I don't know if this is because the page needs to be better loaded. So, the page uses an infinite scroll. So you must keep scrolling until you reach the bottom. So maybe I just need to give it a little bit more info. So let's try to start this over. And actually, one thing I want to do, because it's interesting that no actions are really taken that I can tell on the scroll to the bottom. I'm wondering if it has to do with not being able to access the MCP servers or something. Okay. So it seems like this is busted. I think it just scrolled. So I think we're like getting somewhere. But if anything, this really highlights just how difficult it is to like make agents work reliably. So one thing I'm going to do real quick, just to make sure we're always running the MCP servers that we need, I'm going to switch this up a little bit so that the nodes start the MCP servers. So I think we're coming up on 45 minutes. I think I'm going to basically cut the stream here. But I think my next it it would be nice if there was something at the bottom of the page here, like a copyright or something we could link into. But it doesn't seem like we have something like that. So I think we're kind of going to come back to this. So, oh, we got an error. Okay, so 400, this model's maximum context length. Okay, so as it was trying to scroll down, it literally just uh, hit the uh, total message size. I think like one thing that's problematic here is we're not seeing the tools that are being called because ideally this should literally just keep calling scroll. Um, and so I think something else is going on that we can kind of debug later. But hopefully this gave you like a little idea. We'll probably continue this on another live stream later. But yeah, thanks for watching.